So this is going to be your only video lesson for this week. And we are going to be using those law of sines and those law of cosines that we looked at last week to help us solve these word problems. You need to figure out which one to use based off the information that you are given. You always want to look to use the law of sines first, since it is the quickest. And if we do not have enough information to use the law of sines, then of course we will use the law of cosines to help us find our answer. So on this first example, it says the figure shows a 1,300-yard long sand beach and an oil platform in the ocean. The angles made the platform from one end of the beach is 83 degrees and from the other end is 75 degrees. Find the distance of the oil platform to the nearest tenth of a yard from each end of the beach. So we've got a figure here. You can see that you've got 2 points on the beach that are 1,300 yards apart. The angle from this point in the beach to the oil rig, and the measure of this angle from this point on the beach to the oil rig. And they are wanting us to find both of these lengths. Okay, you can name these anything you want. Since we're familiar with using A, B, and C, that's what I'm going to use. So I'm just going to call this point on the beach A, this point on the beach B, and I'm going to call the oil rig C. So that means we need to find side A and side B, and then we would have our answer. Again, remember, we're rounding to the nearest tenth of a yard. That's one number after the decimal. So looking at what we have, remember, in order to use the law of sines, we have to know both a side and its corresponding angle. So we know angle A, but we are looking for side A. We know angle B, but we're looking for side B. And we know side C, but we don't know angle C. We would need to know what this angle is here at C in order to use the law of sines, because then we would have both parts of side C and angle C to use for that set part of the proportion. So we're not given angle C, but we can quickly find it. Because again, remember from geometry, no matter what the triangle looks like, all angles of a triangle add up to 180. So I can quickly subtract 83 and 75 from 180, and I get 22. So now I know that angle C is 22 degrees. Now I have enough information to use the law of sines. So since I know angle C and side C, I definitely know I'm going to use that fraction. So let's say we want to do A first. So to set this up using the law of sines, we would take side A, which is what we're trying to find. We're going to divide that by the sine of angle A, which is 83 degrees. And then we will set that equal to the fraction of side C, which is 1,300, divided by sine of angle C, which we just quickly found to be 22 degrees. And so now I can cross multiply, getting A times the sine of 22 degrees divided by, or equal to, 1,300 times the sine of 83 degrees. In order to get that A by itself, I've got to divide both sides by the sine of 22 degrees. So now, if I plug this into my calculator, I can get my answer. So 1,300 times the sine of 83 degrees, that answer divided by the sine of 22 degrees. It said round to the nearest tenth, so that gives me 3,444.4 yards. So that's the distance from point A on the beach to the oil rig that's sitting out there in the, from point B to the oil rig that's sitting out in the ocean. That's the distance. We're going to do the exact same thing to find side B. So this fraction here is going to stay the same. This one's just going to reflect what B. So we have side B divided by the sine of angle B, which is 75 degrees. And then we'll keep that same second fraction, 1,300 divided by the sine of 22. We'll cross multiply, so B times the sine of 22 degrees is equal to 1,300 times the sine of 75 degrees. And then we're going to divide by the sine of 22 degrees. So if I plug this into my calculator, 1300 times the sine of 75 degrees, that answer divided by the sine of 22 degrees, rounded to the nearest tenth, is 3,352.1 yards. So now we're finished because we have found the two pieces of information that they were wanting us to find, which was the distance from each point on the beach to the oil rig. And I rounded to the nearest tenth and made sure to put my units of measurement. On the next example, we have a tower that is leaning at an angle of about 84.7 degrees. So you can see that angle here. The figure shows that 157 feet from the base of the tower. So we've got that distance of 157 feet. The angle of elevation to the top is 52.6 degrees. So you see that angle reflected here. Find the distance to the nearest foot from the base to the top. So you can see that they have that labeled B. So we're only trying to find B here. So again, we always want to look to use the law of sines. So if I am trying to find side B, I need to know angle B, which I do. And then again, I need to know the side and the angle of either A or B. Well, I know the angle A, but I don't know side A. And I know side C, but I don't know angle B. But just like on the last example, all triangles add up to 180. So I can quickly subtract the 84.7 and the 52.6 from 180 degrees, and I get 42.7 degrees. So now I know side C and angle C, so I can use the law of sines. So I'm trying to find side B, so I'm going to start with that one. So side B divided by the sine of angle B, which is 52.6 degrees, equals side C, which is 157 feet, over the sine of angle C, which we just found to be 42.7 degrees. So now I can cross multiply. So I have B times the sine of 42.7 degrees equals 157 times the sine of 52.6 degrees. To get B by itself, I'm going to divide both sides by the sine of 42.7 degrees. So B equals, I'll put this in my calculator, so 157 times the sine of 52.6 degrees. That answer divided by the sine of 42.7 degrees tells us to round to the nearest foot. After the decimal is 0.9, so I'm going to round up. So I have 184 feet for the distance between the base of the tower to the top of the tower is approximately 184 feet. On this last one, move the camera down here. Suppose a certain baseball diamond is a square 91 feet on a side. So hopefully we're familiar with what a baseball diamond looks like. We'll call that good enough. And we are told that each side is 91 feet. So I'm going to label that on all four sides because it is supposed to be a square. So then it says the pitching rubber is located 60.5 feet from home plate on the line joining home plate to second base. So if I draw this line connecting where second base would be to where home plate is, and I just pick some random spot for where the pitching mound is. So we'll say right there is the pitching mound. We know that the distance between the pitching mound and home plate is 60.5 feet. Okay, so that's what we have as a picture based off of the information we're given. How far is it from the pitching rubber to third base? So third base is over here. So we want to figure out how far this is from the pitching machine or from the pitching mound. So we're trying to find that distance there. I'm just going to label it X. Remember, no matter whether we're using the law of sines or the law of cosines, we have to know at least one angle. And right now we don't have any angles, but I want you to think back to geometry. When you were working on two-dimensional shapes, one of them being this square, What do you know about all the angles inside of a square? Well, all the angles inside of a square are right angles. So all of these would be right angles. And if we're cutting home plate and second base in half, because we're drawing a line that joins the two of those, if we cut 90 degrees in half, half of that would be 45 degrees. So we now know that this right here is 45 degrees. Okay, I'm only going to work with the things that are inside this triangle here, because this is what we're going to have to use to find that distance between the pitching mound and third base. So I know this is 45 degrees. So now I at least have one angle. There's no way for me to find these other two angles. So there's no way for us to use the law of sines on this problem. If you remember the law of cosines, you needed to know at least one angle, and we have that. So let's call this A, this B, and this C, just so we have those to reference. Opposite angle A would be side A, so this would be A here. This would be B. We're looking for C, and we know angle C. So using the law of cosines that starts with your C, you would have C squared equals A squared, which is 60.5, so 60.5 squared, plus B squared, which is 91 squared, minus 2 times A times B cosine angle C. So we have all of our information. And remember, with these, we can just plug those directly into the calculator. And when we get that answer, that tells us what C squared is, and then we'll have just one more step. So if I plug this in, I add 60.5 squared plus 91 squared minus 2 times 60.5 times 91 times the cosine of 45 degrees. So I get the decimal in my calculator of 4,155.2972232. So that's what what the answer is in the calculator. I still need to square root this because I got to get rid of that square here in order to get C by itself. So I'm going to square root everything. So when I square root that answer in my calculator, it does not tell us how to round. Based off the information we were given a whole foot here and a 1/10 of a foot here. So let's just round to the nearest 1/10. So in your calculator, you'll have 64.5 feet for your approximate distance between the pitching mound and third base, 64.5 feet. There are 2 assignments for this one lesson, so please make sure you check Google Classroom and follow the directions for those assignments.